Hello Math 20-2 and welcome back to your third lesson statistics, which deals with normal distribution. So what is normal distribution? Normal distribution is when a graph makes a nice little curve where it's evenly distributed throughout and one goes up and then down. Okay, these curves tend to be symmetrical. If I look at these here and I go from the midpoints of each one of these plots, I get curves that look like this. If you look at them, they're nicely and evenly distributed. And they make something called a bell curve. All right here's the bell curve. Now, it's called a bell curve because when you put a bell and you look at a bell, it kind of goes down like that. Nicely, just like this is. So that's why it's called a bell curve. Okay? Now, if it makes a bell curve, it is said to be normally distributed. Okay? Now, that means there can't be a little lump going up like this or anything like that. It has to look perfectly like a bell. All right? So, if we look at this here, I'm going to just skip over this. I'm just going to show you can follow this if you want, which I recommend. You end up making a little bell curve like that there. So all of these here can make little bell curves. All right? Now, I'm going to start off right here by going over some important numbers that you'll have to kind of memorize. The more you do them, you'll eventually start memorizing. So we're taking a look at this here. There's some statistics normally distributed. Now, when we look at a bell curve, the area under the curve is always 1. So then, if I say 0.34 of the curve is between here and here, that means 34% is under. So the area is 1, and their or 100% is under the bell curve, right? Now, the bell curve goes forever in both directions. It's another thing to know. And it is also symmetrical. So this side is going to be equal to this side. And this part here is always our mean. Okay? So let's start off with some simple calculations. The mean of the data is always 0. Okay? It's 0 standard deviations away. Now the standard deviation of the data is, if I look at this, it is just going by 1. Okay? The z-score is 1. Now it says the percentage of the data that is above the mean. So here's my mean. What percentage of the data is all the way that way? Well, the mean is right in the middle, and this is perfectly symmetrical. So half of the data must be this way, and half must be that way. If I added up all of these percentages, that should give me around 50%. Okay? Now, what percentage of the data is within one standard deviation? Now, as soon as it says this, within one standard deviation, it doesn't say one standard deviation above or one standard deviation below. It says exactly within one standard deviation. Now, I have to look at this. That is +1 or -1 standard deviation away. So I have to add these two together, and I'm going to get 68.26%. Then it says, what percentage of the data is within 2 standard deviations? So that's 2 below the mean and 2 above the mean. So I have to look here. I go from here all the way to there. Okay, now I add these 4 percentages up, and I'm going to end up getting 95.44%. Okay? Now, the next one says, what percentage of the data is 3 standard deviations above the mean? So we want 3. So that's from here to here. Oh, 3 standard deviations, within 3 standard deviations of the mean. So I have to go 3 below and 3 above. Well, I have to add on then 2.15 and 2.15. So that's 2.3% altogether. Or sorry, 4.3% altogether. So that's going to end up giving me 99.74%. Okay, because we add 4.3% to 95.44. Now the next one here says percentage of data between 1 and 2 standard deviations. So where is 1 and 2? That's from here to here. And I look at that, that's going to give me 13.59. 13.59%, or 0.139 of 1, which is 13.59. The last question is the percentage of the data between 1 and 2 standard deviations. So So percentage of the data between 1 and 2 standard deviations. Below the mean. Last one was above, this one's below. So we have to go 1 and 2 below, which is going to give me 13.59. Now here's a curious thing. If we notice, this here and this here is the same. So if we are between 2 and 3 below the mean and 2 and 3 above the mean, our percentages are the same. Because remember, it's a normal distribution. It's even on both sides. Okay, it makes a perfect bell curve. That'd be a funny looking bell if it kind of, just draw it right here, looked like that. Doesn't really look like a bell, or something that looked like this. That's not really a bell. It has to be perfectly even throughout. That's a better bell curve. All right? Now, here are some definitions that I recommend you highlight. So the total area under the curve is 1. Okay? The normal curve extends infinitely left and infinitely right. The curve is perfectly symmetrical at the mean. The mean, median, and mode are all the line of symmetry. Okay? They're all always equal to the same thing. The data represented by the area under the curve. So all the data goes in the area under the curve, and that's about it. So it's 50% this way, 50% that way. All right? Now, here we go. Here's our first class example. It says, a nurse is recording how long or how many hours an infant sleeps. He then makes a bell curve to figure out percentages to help him come up with averages. Okay? So it says, what is the mean of the data? Oh, this, by the way, is our standard deviation. What is the mean of the data? Well, that is my line of symmetry. Right there's my line of symmetry. So my mean is equal to 12. That's 12 hours of sleep. Okay? Next one says, what is the standard deviation? Well, I look at this. I'm always counting by 2 this way. Right? And this here, I'm going by 2 down. So my standard deviation is 2 hours. Okay? Now it says, what are the values of A, B, C, and D? Well, I look at this. We go down by 2, then we go down by another 2, then we go down by another 2. So this is going to have to be 8, and this is going to be 6. Here we're going up by 2 every time, so 14. This is going to be 16. This is going to be 18. Another way of doing this would be, well, look at the standard deviations. This is 0, 1, 2, 3. 1, 2, 3. And I know each standard, oh, these are negative. And each standard deviation is, each standard deviation is 2 away. So 3 times 2 is 6. So we're 6 above the mean, so that's plus 6. That's how we get 18 for D. Let's look at B. B is negative 2. Negative 2 times 2 is negative 4. So we are 4 below the mean of 12. So 12 minus 4 is 8. So that's another way of doing it. So here we get our means. They are 6, 8, my points are A is 6, B is 8, C is 16, and D is 18. Okay? Now, it says, what percentage of days to the nearest 100 does the infant sleep? Okay, so between 12 and 14 hours. So let's look, 12 and 14. That's 1 standard deviation away. So for that one, I'm going to go back to this here. 1 standard deviation away is between here and here, which is 34.13%. Always go back to that page maybe for a while. 34. In your thing, in your assignment. Now between 8 and 16 hours. So 8 is here and 16 is there. That is a total of 1, 2 above and 1, 2 below. That is a total of saying within 2 standard deviations, how much does it sleep within 2 standard deviations? We did that one. There to there, which gives me 95.44%. Okay? Now, the last one says less than 6 hours. So less than 6 hours is right here. Well, that is less than the 3rd standard deviation. So what's under the 3rd standard deviation? That's 0.13%. So that is 0.13%. Let's look that way. Now, why is it not possible to determine 13 hours? If I look at 13 would be there, Well, that is half a standard deviation away, isn't it? And here, we only know for the full standard deviations based on this. So it's because it is half a standard deviation away. And we only know full. We will get to solving this a little bit later. So here we go. Here's a little review of certain things. Okay? So, with z-scores and everything. So it says, consider class example 1. So we're looking at the babies again. It's filled out for us. So the data value 18 is how many standard deviations away? It is 3 standard deviations away, which is the z-score of -3. Okay? The data value of 8 is how many standard deviations away? It's 2 below. It is 2 standard deviations below, 3 standard deviations away, which is +3, because it's 3 above. Anytime we see below, if it's below, it's going to be -2. The data value of 12 is the mean, 0 standard deviations away from the mean, so the z-score is 0. The data value of 13 is, well, half a standard deviation above, and since it's above, it's going to have to be +1/2. So, number of standard deviations away in terms of the mean, well, that's pretty simple. We're going to look at this here. I'm going to have, it is the mean, subtract 3 standard deviations. This is the mean, subtract 2 standard deviations. Here is the mean, subtract a standard deviation. Here's just the mean. Here is going to be the mean plus standard deviation, the mean plus 2 standard deviations, and the mean plus 3 standard deviations. So that's what's happening here. Now, when we write a standard deviation form, it's a lot longer than writing it in z-score form. Okay? This value here was the mean, right? 12, subtract 3 standard deviations, so 3 times 2, which is 6. 12, subtract -6 is there. So this is just -3. -2, -1, 0, 1, 2, 3. That's it. Okay? Now, how can the z-score of the data of 13 be determined? Calculate the z-score of the value of 13. List both the data values on the z-score and the normal curve. So how can we determine that? The z-score of 13 is equal to 0.15. Or sorry, 0.5. Because it's halfway between 12 and 14. All right, so here we go. Quickly on to example number 2. We have here, it states, complete the following. Approximately 68.3 of the data lies between which two z-scores? Well, -1 and 1. Approximately 95.4 lies between z-scores -2 and 2. Right? If we add all of this together, that's going to give me 95.4. 99.7 is between 3 standard deviations away, so that's -3 and 3. Good. Easy. Here is also something you might want to highlight. This is your formula for your z-score, as we're going to be looking at that a little bit later. So here in example 3, we have the heights of five starting members of the basketball team, or a basketball team. And it already tells us the mean height is this. The standard deviation is 15. Calculate the z-score to the nearest hundredth. Okay, for the tallest player. Then calculates the z-score for the shortest. So for this one here, they already did the 170, which is the shortest player. So now we want to do for the tallest player. So the z-score of the tallest player is going to be 212, which is equal to x, which is 212, the player we want, subtract the mean, which is 190, or the data point we want to know how it's related to the rest, which is 190, and then we have to divide it by 15, the standard deviation. What does that give us? That is going to end up giving me a total of 22 divided by 15, which is equal to 1.47. So in this next one, we're looking at Tony's report card. We're comparing his mark to his mean mark and the standard deviation for the class. So what we want to do here is determine his Z-score for each one to figure out which one did he do best in. Now, the higher the Z-score, the positive means he did very well compared to the rest of the class. The lower the Z-score means he didn't do well to the rest of the class, okay? So if it's negative, he's way below. The higher the negative, it's not very good. So let's take a look at math first. So we're going to go Z-score of math. Okay? Well, that is the same. What is the mark he has? His mark is 74. The mean is 68 and a standard deviation of 12. I calculate that, I'm going to end up getting 6 over 12, which is a total, I'm going, 74, 68, yeah, 6 over 12, which is a total of 0.5. Now let's take a look at the next one. His Z-score for chemistry is equal to, we have 79 is the score that we want, that we're looking at, compared to the mean, which is 73, so we subtract the mean, and we divide it by 14, which is how the data is distributed. It's 14, it's going to be put together. Now, I look at this here, and we're going to end up getting 0.43. And the last one is the Z-score of physics. Okay? Well, his score is 68, so the score we're looking at is 68, and the average is 66. We want to know how far away he is from the average on that, and that's going to be 11. And so what we end up getting here now is 0.18. So which one did he do best in? He actually did the best in math compared to the average. Even though his chemistry was the highest mark, he did the best in math compared to the averages of everyone else. Okay? Now, here's the next one. It says, the average mark on an English exam was 63, standard deviation of 12. So we know my mean is equal to 63. My standard deviation is equal to 12. Okay, if the marks are normally distributed about a Z-score and the student's mark was 1.5, so we're saying the student, Z-score of the student is equal to 1.5. We want to know what the mark of the student is. Well, so let's put it into our formula. We have 1.5 is equal to, well, we don't know the student's mark. Okay, we're still using this formula way up here. All right? And then we have to subtract the mean, which is 63, all over 12. All right? Now I'm just going to kind of rearrange that right here. So I'm going to multiply that by that. So I'm going to get 18 is equal to x, subtract 63, add 63 to both sides. Okay, first I multiply both sides by 12. 12, trying to solve for x, right? Add 63 to both sides. I'm going to end up getting x is equal to 81. So the student got a mark of 81. Okay, let's look at question example number 6. And here we're looking at the weights of large shipments of cantaloupes with a normally distributed of 2.3 kilograms. Okay, so the mean is 2.3. Okay, the weight of a particular cantaloupe is 1.4. Make sure they're in the same units, good, and which is 1.01 standard deviations below the mean. So my Z-score, if it's below, that means it's negative. My Z-score is negative 1.01. So we want to find out then, obviously, the standard deviation. So we put this in. So we know, looking at our formula, is equal to x minus mu over standard deviation. We know my Z-score is negative 1.01. We know my x-score is 1.4. My mean is subtract 2.3, and it's all over standard deviation. So we have to try and solve the standard deviation. How am I going to do this? Well, I'm going to first switch these two around to isolate for standard deviation. So the standard deviation is equal to 1.4 minus 2.3 all over negative 1.01. Okay, now I'm going to solve for that, and I'm going to end up getting 0.59 is my standard deviation. That's a kilogram. So our last one here, we have a professor who gave a math test. he found the mean to be 52 and a standard deviation of 12. Now, the professor here thought this exam was too difficult, so he was nice and decided to adjust the original marks by raising the mean to 65. So I'm going to say mean, I'll put an n for new, is equal to 65. Okay? Now, and then while reducing, he also reduced the standard deviation to 10. Okay, he's trying to be nice here, leaving the z-score unchanged. So the z stays the same. Okay? What would the new mark of a student who got 34? So 34. So we want to find the new mark. But first we have to find the original z-score. So x is equal to 34. So now we want to find this x here is equal to a question mark. So we have to find his z-score because the z-score is unchanged. So I'm going to take this here and we go z of the 34 of the student is equal to 34 minus 52. Because, right, the student's mark, subtract the average, because we want to know how far away it is on average from the average by the standard deviation. Now, we have to try and solve for the standard deviation. So, standard deviation is 12. My mistake. Now, we have to try to solve for that. So, my z-score for this 34 mark for the student, is actually equal to negative 1.5. So, he didn't do too good. He was quite a bit below average. All right, he was very low. We could go back and say the percentile. We could say he beat only right here. If he's 1.5, like he's around right there. So it's maybe, I don't know, less than 20%, something like that. So we have 1.5. Now, we want to figure out what is his mark on the new one. Okay, so the z-score here is, let's try the new one. We know the z-score is negative 1.5 is equal to x subtract, and my new mark is 65, and my standard deviation is 10. Okay? You can't really change the z-score for this because that's how far you are away from the mean, the average. Now, this changes. We have to isolate for x. So I'm going to multiply both sides by 10. So I'm going to get up here, I'll just put it up there. We end up getting 10.5, negative 10.5 is equal to x subtract 65. So I'm going to plus 65 to both sides, and I will end up getting x is equal to 54.5. And that is his new mark. Okay? So, 10.5, this should be 15. My mistake. 10 times that is 15. So his new mark is 50. 50. So then he ended up just passing. And that's how we do that. So, good luck as I see you tomorrow to work on this together.